So part B, now this one we're not going to be able to use the unit circle for because 4/7, that's not a ratio.
It's no deal there.
That we see on the unit circle.
Yeah.
So start off here finding the modulus. Remember to put that negative in parentheses.
Yeah, if you don't put it in parentheses, you're going to get an imaginary number. And guess what? This isn't where that's supposed to happen.
Right.
Imaginary number happens in a minute, not right now.
But your modulus should not be imaginary because it's a distance.
Yeah, it's a distance. Like if you get in your car and you drive, your odometer goes forward. That's what we're doing here. Doesn't matter what direction you go, odometer's moving forward.
Right on, right on. 16 plus 49.
362.
Could you be for real? Just for a moment. 16 plus 49. I believe it's 65.
16 plus 49. Whoops. I'm just going to double check because 16 plus 49.
This is important.
We got to get to 65.
Okay, so
we
the
got to get that
modulus,
one right.
the R in our formula is square root of 65. Now, I want to think about where in the world is 4 negative 7? Well,
4
down here, right?
negative 7, yes.
Okay, and so our calculator is going to give us this angle. And so if we want the legit angle, like the real one, then we would do 2 pi minus that angle because it's over here.
Right.
We're going almost all the way around to right there. So inverse
how short
tangent,
of 2 pi are we? That's what we want to know.
Right, and because we know this isn't on the unit circle, I'm going to put this in radian mode, and that means it's going to look kind of funny because it's going to give us a decimal. Weird. And our calculator is going to tell us it's negative
1.052.
Okay. And so what we have to do, you have to make sure that you realize this. We're doing 2 pi minus that number, and if you do 2 pi minus second answer, it's not going to do what you want if that negative is in there.
7.3348. 7.335.
What is 2 pi?
2 pi is...
you just did what I told them not to do.
Dang it!
You minus the negative. I was like, that's bigger than 2 pi.
What I meant to say was...
This is an example of what happens if you do 2 pi minus a negative 1.052.
Why would you say that about me? 5.232.
That right there. That is our theta for the problem.
You wounded me, why?
I'm sorry.
You offended me greatly.
5.232 cosine. That's not where that
goes.
No.
Square root 65.
No.
Why would you do that? There you go. Now get your 5.232 in there. And usually we want to go 3 decimal places. Every now and then one more or so, but we'll let you know when that is. 3 is a pretty safe place.
Yeah. There you go. We just plugged in R and theta once we had it. That's our answer right there.
Yep. And if you do this correctly, if you distribute all of this out.
It should
come back to 4 minus 7.
It should come back to 4 minus 7i.
Way to copy me. That's a great job.
True story.
Yes, true indeed. Okay.
So, and incidentally, that's what example 3 is about.
Shut the front door.
No.
You
Write the complex number in standard form. All we have to do is distribute.
Hey, by the way,
evaluate.
This one should have no decimals for your answer here because
this 30
is on the unit
is
circle.
Pretty clearly on the unit circle. And so you go to cosine at 30, that would be square root of 3 over 2.
Yep, square root of 3 over 2.
So cosine of 30 is square root of 3 over 2. I'm doing it this way. You could do it a slightly different way if you wanted to. I just thought I'd figure out what cosine and sine were. Yeah, 1/2. That's right. Sine 30 is 1/2. Now we want to distribute the 3, so that's 3 square roots of 3 over 2 minus 3/2 I, because typically we put the I at the end.
Usually, or you could also see it as 3i over 2.
Yes, you could. You could do that.
Yeah.
You could say that's 3i.
I doesn't usually go in the front, though.
I don't know. Sometimes
I don't either. That's
a good one. Yeah, totally.
I think this example's over.
Yeah.